Welcome everyone to today's webinar. Hopefully we'll get an opportunity to introduce our healthcare system engineering program here at Lehigh. We're also very fortunate today to have a number of our students, distinguished students actually, that will be able to also answer some of your questions. The format of this webinar will start with an introduction about the status of healthcare in general, just as a quick overview. Then we'll get into our program here at Lehigh as a healthcare system engineering program, and afterwards we'll open the room for questions and answers. Also, just to note that this webinar will be recorded, and we will be mailing everyone on the list that registered for this webinar a video link that they can watch it at a later time also. And at the end, the last slide has also my contact information and Linda Wismer's contact information, our coordinator, and we'll be more than glad if we don't get to all the questions today. We will be more than glad, and we will be contacting you to answer those questions that we were not able to answer. So before we start, we'll do some introductions of those that are in the room. My name is Hisham Abu-Nabaa. I'm the director of the Healthcare System Engineering Program and a professor of practice in the Industrial and System Engineering Department. I'll go to Terry.
My name's Terry Theman. I'm a cardiothoracic surgeon, semi-retired, and a part-time student in this program.
I'm David Adinaro. I'm a part-time student also in this program and currently the chief of the Adult Emergency Department at St. Joseph Regional Medical Center in Paterson, New Jersey, and Lehigh alum from way back.
I'm Michael Kimball. I am a recent graduate of the program. I just finished this past June. I also did the entire curriculum as a distant student, and I'm currently working at Lehigh Valley Health Network as a senior management engineer.
My name is Robert Rodgers. I'm currently a full-time student at Lehigh University. I recently transitioned from a part-time student to a full-time student, and I too am a distance ed.
Well, here we go. We got an introduction of both on the clinical side and on the operational side of the types of students that enroll in the program, and hopefully you'll be able to listen to their stories of why they joined the program. Just to start with a quick overview, and this has been common knowledge that has been published over and over with all the buzz on in the news and media about healthcare reform. The amount of spending, according to some of the reports, between $2.7 to $2.8 trillion of spending, and if you look at that percentage of GDP compared to manufacturing and government spending, you would notice that it's a bit larger. So there's a major national interest in reducing that number and reducing the cost of healthcare in general. A lot has been done over the years to try to reduce that number, including the introduction of quality control concepts such as Six Sigma and Lean. A lot of introducing some of the healthcare electronic systems such as the EMRs and EHRs, electronic health records, and electronic medical records. But yet a lot of the research showed that the introduction of these systems or new technologies has not really helped in the reduction, for example, of waste and the reduction of the inefficiencies that actually exist, or the reduction of cost. And we're going to discuss some of the ways that healthcare system engineering can actually tackle and solve some of these issues, increase efficiencies at the same time and quality, and at the same time decrease the cost that is associated. So there's just the following couple of slides, or four slides, just gives you an overview of the healthcare status and also gives you an indication in terms of the job market. For example, 10 out of every 20 new jobs is in the healthcare arena or healthcare industry, and these jobs are constantly growing with the growing elderly population, with the increase of the Obamacare in covering some of the uninsured in the past. So that's a growing market, and there's a need for a solution because of a problem that is growing with the growth of the need of patients or the patient needs. So one of the things that Lehigh has done as an initiative as a university is wanting to approach healthcare as one of its lead topics of interest and of research for as a strategic plan for the future. And we do not have a medical school, so it really allowed us as a university without a medical school to be able to collaborate nationally with a variety of different industries that we will be able to talk about later in the presentation. This is just a quick overview of some of the growing trends and evolving trends within the healthcare. We talked about the electronic records using advanced technologies, and also the use of quality control concepts and quality like Six Sigma and Lean as a means of improving the quality of care. We want to keep in mind that despite of all those efforts, that we do have approximately 100,000 deaths a year due to medication errors and more than 1 million injuries due to medication errors. So there's a lot of room for improvement. Our goal is not to eliminate variations within healthcare, but as much as to do a reduction of these variations that could cause these kind of problems. An introduction of more of the automation or automating some of the systems that are out there would be also some of the things that we're trying to tackle through this program. So we'll start with a quick overview of what the program is. Again, healthcare system engineering, from the definition of the word systems, is really looking at healthcare from a multidisciplinary approach. We don't look at it only from the technology side. We don't look at it from the administrative side, but a combination of both, topped with using advanced and sophisticated mathematical modeling tools that actually help us in the decision process, that your intuition wouldn't be able to actually come up with this optimal solution to the majority of the problems. So it's a multidisciplinary approach that includes, and again, you can notice that multidisciplinary approach from the courses that we're offering, and at the same time the student body and the audience that we're trying to attract to this program, and that's where the multidisciplinary factor comes in, and it enriches the type of discussions we have in the class and the type of problems that we're actually tackling, because we involve so many people from the spectrum of the different industries into the problems that we're actually tackling. Here's just an example of some of the audience that would be fit for this program. Consultants, people, recent graduates from various programs. We have people from mechanical, electrical, computer science. Also, we've noticed a trend of a number of our students who are going into medical school, taking a year off as they prepare for their MCATs and prepare for their medical school, to have this master's degree as something that distinguishes them from the rest of the students going into medical school. Clinicians, and we'll hear more today about why they joined the program and how it adds value to their workplace by taking these courses, administration in general, executives, and so on. So there's a wide variety of different people. It's a wide spectrum of people that can actually join the program and be part of the program. Our program is a 30-credit program divided into 12 credit hours in the healthcare system engineering core and 9 in the foundation ISC industrial and system engineering courses, and 6 credits worth of elective courses, and 3 of our engineering capstone, which is our signature course where we allow our students to participate with industry, if it's the providers, the payers, government regulatory agencies, and have that hands-on experience as it relates to these type of problems and solutions that are associated with this. It can definitely be completed in 1 year. Mostly the students that are coming in for the medical that are pre-med completed in 1 year by taking basically 12 spring, 12 fall, and 2 courses in the summer, which mostly end up being their project. But the average student completes it in about a year and a half. Half our students are working, are employed and full-time workers, and basically they complete it in about 2 years. So you just get an idea of the type of students that we currently have in the programs. We're going to get into some more details of what are the core healthcare system courses and ISC foundation courses. So we'll start with the healthcare courses, an introductory to healthcare systems, and Mike may be able at a later time describe how that course is, even though he comes from a healthcare background, he mentioned of how that course really influenced his opinion about healthcare and introduced more of the spectrum of healthcare than just a narrow spectrum from working in one department or one area within healthcare. Healthcare quality and process improvement, where we cover a lot of the standard Six Sigma Lean total quality management. Financial management in healthcare. We're fortunate that this course is being taught by a previous COO, Chief Operating Officer, and Chief Financial Officer of one of the large medical provider organizations within our region. Healthcare information technology also covers a lot of the general ideas about how data mining, and information is being covered within the healthcare HIPAA regulations, the different formats of the data that is being transitioned between the different systems within healthcare, the interfaces, for example, the HL7, a lot of the regulatory issues that are related to data transformation or data being moved from one place to another, or being shared by different resources within the industry of healthcare. Now, the introduction to healthcare systems is also being taught by the president of Paragon RX, which is a pharmaceutical consulting firm. Again, trying to bring more of the leaders of the industry to teach some of these courses has been a really added value to the teaching experience that the students go through. The system foundation courses, and again, this is what really distinguishes our program from a traditional healthcare administration program or a healthcare informatics program or any of the healthcare existing programs. There's about 5 programs in the country, and the number is growing, that are actually teaching healthcare system engineering, and Lehigh University is one of those 5 universities giving a master's degree in healthcare system engineering. And what really distinguishes the healthcare system engineering is these courses. The simulation course, we use Arena as part of the teaching process, as part of the course, but we also allow our students, with a partnership with a company called Flexim, also to be able to explore another type of simulation software. And I want to distinguish between what we call here simulation and what healthcare calls simulation, using mannequins or other tools to try to do patient training or physician or nurse training. This is what we mean by simulation here, is computer simulated software that allows us to do what-if analysis, for example, for an existing setup within an organization or within a healthcare industry, and more specific, at a minimal cost, because what you're doing is being able to put in raw data that is relevant to your historical data that reflects the real-time events that are going on within the organization, and be able to play around with that and see what-if analysis that is of great value to the organization, and would be able to make decisions based on the outcomes of that. And it also allows you to identify root causes of problems and bottlenecks and so on. Statistics course, or design of experiments, is the IE 410. Optimization modeling is also a signature course where we do a lot of the mathematical modeling of existing problems. And this is not only, again, we use linear and integer programming, but the course is not just focused on the operational type research. We can also do optimization modeling. For example, what is the optimal dosage for chemotherapy? So we can do it on the clinical side also. And the last course is probabilistic models, IE 429, again concentrating on the stochastic nature of some of these processes and models. And as we know, a lot of the events in this complex system of healthcare, most of it is random events that need to be mathematically modeled. Now, we talked about these courses. Let me just go back to the slide, and you notice it's math intense. And what we've done is we've created an extra couple of courses, an introduction to industrial and system engineering statistics and probability, and another course that introduces the linear programming and linear algebra course. And basically it preps the students for these more math advanced courses if they come from a clinical background and or come from a background that did not cover some of the calculus and math courses. We don't really get into a lot of the differential equations or anything like that that is more in advanced calculus 2 and 3. we're more concentrated on linear algebra and algorithms that are used within these courses. The electives, we leave it open for the students to select 2 electives from different departments, including the business, the IT, industrial engineering, and other disciplines within the university based on their background. So if somebody's, for example, an IT background, they might be more interested in database management or cloud computing and so on. So those are different topics that we leave it up to the students to select given their backgrounds and given the fields of interest. The capstone, which is the last course, again, this is our opportunity to put the students within the healthcare industry to have that hands-on experience and really distinguish the students. Usually by the time they graduate, they would have 1 or 2 or 3 times projects that they've completed and worked on as part of teams or as an individual assignment. We allow the students also to seek companies, not only projects that we bring to the table, but they are also allowed to go and fetch projects within their own organization. So for example, if you're working in a hospital and you have a perfect project that is relevant to your work, at the same time relevant to the coursework that you're taking at Lehigh, you are allowed to basically use that as part of your capstone project, but it's controlled by regulatory requirements of what a capstone project would require. All of these courses, all 30 of them, can be done distance, so you can be anywhere around the world and you would have the capability of watching a video recording or watching it live or being in a class setting very similar to the class that we're in right now, where you have video recording and interaction with the students and with the faculty that is teaching. The different types of areas once you complete those courses that you can be working in, it could be simulation, systems modeling, simulation, human factors, and analytics in general. We'll leave the students to also talk about their areas of work at the end, and hopefully you get an idea of how these courses can be implemented in real life examples within the different industries, specifically in the provider industry or the hospital settings. So these are just simple examples of projects, some of which our students have been working on, some of which are available in industry, just to give you an idea. So this is this covers some of the operational management type projects. So for example, we've done a lot of predictive modeling to try to predict what patients, for example, will be rehospitalized within 30 days based on readmissions for the hospitals and 60 days for home care. And we were able to develop models that gave a good prediction system or gave good forecasting capabilities for these industries to target certain categories or classifications within those patients to prevent them from being rehospitalized. A lot of other projects have been focused on simulation and how to use simulation as a tool of decision making within these organizations. On the clinical side, we talked about evidence-based cost-effective diagnosis. We talked about optimal dosage for chemotherapy, organ transplant assignment. All of those are things that can be used, and currently we're trying to work with the FDA on some of the risk, on the REMS and risk analysis that they're actually doing, and how to use these tools in their organization as also within the pharmaceutical industry, that is. Our leadership council, one of the things that we wanted to do is make sure that we reach out. Again, this is an advantage that we looked at, not as a disadvantage of not having a medical school here at Lehigh, which allowed us to really reach out at a national level and a local level, all of the healthcare industries that are willing to participate with us. And this is just a list of names of some of the industries that we're partnering with, all of which are the C-level leadership, senior leadership are involved in our leadership council. You can find their names and job descriptions posted on our website. But just to name a couple of industries from the provider side, we have Mayo Clinic, Geisinger, Temple, Jefferson, Lehigh Valley Hospital, St. Luke's Hospital, Easton Hospital, Susquehanna Health. And on the payer side, we have Capital Blue Cross, Independent Blue Cross of Philadelphia, Highmark, Cigna. From the hospital regulatory side, we have HAP, Hospital Association of Pennsylvania, Department of Health, the FDA, pharmaceutical, Novartis, medical manufacturers, Abbott, B. Bronze, and so on. So if you can see from the manufacturing, the provider, the payer, the government regulatory side, we have partners in all of those. And and they have been instrumental in guiding us to make sure that this program meets their needs, and at the same time they've been able to give us the feedback necessary to make sure our students are well fit for their organization and well fit to be able to be producing within the variety of different industries that actually exist out there. So with that, that's a quick and brief introduction to our program. I'll open it for questions, and we have Nate that will be moderating this, so please text them your questions, and as the questions come through, hopefully all of us will be able to answer. If you have a question directed to one person in particular, please do not hesitate to indicate so.
The question, do they require the GRE for admissions?
The requirements of the GRE is something that we highly recommend, but it's not a must. And the reason we sort of shied away from having the GRE is because of our clinical type students, that we thought it would be very difficult for a physician to go back and study the GRE. And so far we've had successful completion of the program of clinicians without the GRE. So it's a highly recommended, it helps, but it's not a must for now.
What about transferring some credits into the program?
You're allowed to transfer 6 to 12 credits, well actually up to 12 credits, but that is dependent upon the description of the courses that you've taken, its relevancy to the existing program, and the approval of a number of people, including a committee that looks at the courses and the dean's office. So it's a process that's available, but it's not a guaranteed process that any course will be transferable.
We have a question for one of the panel students. What attracted you to the healthcare systems engineering program? So,
We can, I guess, all of them
Terry,
can
or-
answer that, so we'll start with Terry.
could you repeat the question too, just so folks could hear that?
Certainly. So I'm Terry Theman. I'm a surgeon, and the question was what attracted me to the healthcare systems engineering program. And probably what attracted me the most was I was searching around for a way that I could use my years of medical experience and knowledge and apply it in a different way to improve the healthcare system in America. And I found the Lehigh website, and I was intrigued, and so I made an appointment with Professor Nabaa. And it was really his enthusiasm and influence that tipped me over the edge in terms of getting me all excited about this program. When he explained how engineers approach issues and problems, and how different this is from the way medical practitioners look at solving problems in healthcare, I thought that this was really a key way to apply my medical knowledge and integrate it with my newfound skills and hopefully make a difference. A story I like to tell, and I've told Dr. Nabaa this, is that since I've been in this program, now when I'm in the hospital, I have new eyes looking at medical systems that in the past I accepted as just being, that's the way that business is conducted. That's the culture of the institution, or this is the way that the hospital has found to be the best to accomplish certain tasks. But as you go through this program, you realize that most healthcare systems don't actually analyze various systems to find out which one is optimal, which one is best. And certainly most physicians don't either. And we've lived in a very wealthy and somewhat wasteful healthcare system for most of our lives. And so this program now awakens in the students this interest in looking at things through the eyes of an engineer and looking at ways that we can do things better. And not only can it be cheaper, I think it can also be higher quality at the same time.
Thank you, Terry. Can you give an example of a capstone project that was completed for a hospital?
Well, actually, Mike and both Dr. David Adinaro had projects, so I'll let them talk about it. But if we can go back to that first question, I'd really like to hear their comments about their what attracted them, because they come from a diverse background.
Okay.
That it would be, I guess, of interest to the audience to listen to everyone's what attracted them to the program.
Sure. David?
So, for me, it was I was in search of a program and didn't know what program I was going to land at. I had looked at, as a clinician, becoming more interested in administrative things in a department that has a kind of a relentless quality improvement stance. I was looking for that next thing that was going to provide me a better background as I moved through administration. I looked at MBA programs, and they were interesting, but more towards business. I looked at the Masters in Medical Management programs, and again, they had some management features, but they weren't really system-based. And as a Lehigh alum, honestly, a couple Christmases ago, I'm flipping through the alumni magazine and see the full-page ad for the program. I go, this is what I'm looking for. It's got enough hardcore engineering, so it's like some of the operation research programs I looked at, but it's also a little bit more diverse in terms of giving me some of the backgrounds on the financial side and on the quality side that a lot of those were missing. And it had that right combination. For me, it's, we have a busy emergency department. We're about 150,000 visits. We work very hard to care for the patients appropriately, regardless of the number that come in. It's never the same every day. But it's also, as Terry was talking about, it was versus accepting the systems you have, how are you going to make these improvements? How does medicine find its own voice in terms of quality, in terms of system things? Are we always going to be stealing from the airline industry or Toyota? Where do we make our own mark? And really that's what attracted me to this program, was that ability to have something that's healthcare specific, but give me that background in the engineering that we're going to need to have in the future.
So my background is very different. I actually was in healthcare IT for 10 years, and when you grow up in information technology, you kind of get used to going after the better, faster, cooler, slicker. And what's interesting about healthcare is the more time I've spent with clinical staff, the more I've learned they're all very frustrated and they usually don't know how to fix it. And in IT, you get into that habit of looking for ways to fix things. And that got me very interested in quality improvement. And so I was able to partner with people through my career that had backgrounds in that, and I was able to feed my background of IT with this background of quality improvement, and then I got into project management, and I kind of wanted to make that shift into how to really do quality improvement, but how to do it right. And I sort of went through the same things David did. I started looking through all these programs, and I strongly considered MBAs. And then I talked to Hisham and said, all right, lay it out for me. What's the difference between this program and an MBA? What am I going to get out of this program? And what you really get is this engineering background is very unique. Healthcare doesn't really know what to do with it yet because, quite honestly, this is a little bit cutting edge. And so there's lots of opportunity, and lots of healthcare organizations are starting to really recognize this, and having actually completed the program and gaining that understanding and pushing through all the math, because I didn't have that math background. So I fell in that realm of student that didn't really understand and didn't have the engineering training. It really enhanced the skills that I knew about what quality improvement was like, and gave me new tools to be able to go into healthcare systems and really help them. And I actually tried leaving healthcare for a little while, for about 4 or 5 months, to go to the financial industry, hated it, and came back, because if you're not in healthcare, there's this attraction to it because of what it stands for and why it exists. It's all about helping people. And so this is a further extension of that, where actually, once you're an engineer, you're helping the people who are helping people, and there's satisfaction of that almost as much as the people doing the direct helping.
This is Michael. I too was in IT. I graduated with a degree in computer science. I worked in software engineering and IT. And I wanted to make a transition into healthcare. And through that process, I evaluated MBA schools. I even looked at possibly going for informatics. And one day, I too found the website, the Lehigh University website for HSE, and I was really intrigued by it. I had a very deep technical background, and a lot of that applies to engineering. And for me, the transition is pretty good. Plus, here at Lehigh, you have the opportunity to be a distance ed student. So if you're making a transition between jobs or even moving, you can participate in class at your leisure, or you can participate live as the class is going on, and that sort of flexibility was exactly what I needed for me to make the transition from IT into healthcare, and I think it's been a great decision so far.
I think, Robert, you hit an important point because most of you have used this distant learning experience. I was just wondering, before we get into the other question, is how do you, what was your experience? Did you feel that it was what you were looking for in terms of the educational value, in terms of you being able to participate, be part of the classroom, although you were distant? Did it meet your schedules that are, I'm sure you both work in hospitals and work in different environments. I'm sure that you have a hectic schedule and sometimes you just can't make it to the classroom. Was this of help? Was this easy to deal with in general?
I can speak on that one more time. So for me, when you look at distance ed, it doesn't always correlate with strong engineering schools. So when I realized Lehigh, which is an absolutely great engineering school, had distance ed, it was a sure fit for me because I knew I would get the formal education that you get at a great engineering school. I would then have the flexibility to interact with professors on a great student to professor ratio. And even now when I'm in the classroom live, I interact exactly the same as any other student would be. And if I'm not there, I interact with the professors through emails in the evening, and that's worked out great for me.
Yeah, I think this is, very much like everything else. If you're a distance student, you're in the classroom, you get out of it what you put into it. If you're going to just watch the videos kind of asynchronously, which is most of the time when I was at night after I get back from the hospital, and that's your entire participation, you'll get a good education. But at the same time, the opportunities that exist to occasionally when I was able to be live in the class, come out to Lehigh periodically just to interact with your professors, either, by making a phone time to come or set up a time to come on campus or by email, you get out of it what you put into it. And, the resources are fantastic. The quality of the professors have been great. And, just the knowledge base you're getting, I think, is worth it. But again, you have to decide that you want to be an active part of the process and not just kind of passively take in the information and become part of it. I think the funniest moment is after a couple of weeks of hearing the word evidence-based medicine being bantered around, I guess it was 2 semesters ago in the quality class, I had sent you an email saying, well, not for nothing, but evidence-based medicine is a little bit more than just find the best, the best evidence in a book. And, I should have known I was putting my foot in my mouth because 3 or 4 weeks later, I'm in class lecturing the class about my perspective on evidence-based medicine. So that was a neat opportunity to, be part of the class and get to know the students in the class, even though I'd spent most of my time as a distance student. So, I think those are kind of some unique opportunities that when they come up, you grab them and go, okay, how do I, get integrated into the class as best as possible?
That also happened with Mike and Dr. Theman when they objected to incentives for physicians. They were also lecturing the next day. So. Yeah. But that's basically the flavor of the class, allowing, we're dealing with professionals very well experienced within what they're doing, and it's very important for the class. We're not the physicians, we're not the clinicians, and it would be very important for us to hear from the experts in the field to give their opinion, and that's that systems part. That's the multidisciplinary approach. It's not one way, a narrow focus. It's more of a focus that concentrates on the entire discipline within healthcare. So that's one of the things that we're proud of.
And what I'll tack on to that is, I'm in the area now, but 6 months ago I was living in Massachusetts, so I did most of this program with a geographical distance as well. And my big concern going into this program was, how easy is the communication really going to be? And these guys touched on it. How well are the professors going to write back to me? And are they going to be reliable? Am I going to wait 3 days to get a response? And I have to say, every professor that I wrote back to me instantly. The communication was amazing. You're talking about some complicated things, some math equations that they're writing into email in ways that you can actually understand it. And I really didn't need phone calls. I didn't need any of that. And I was able to get through the work and be successful in the program, even despite that distance and email challenges.
Can you give an example of a capstone project that was completed for a hospital?
Want me to go first this time? So the capstone project that I did was at Lehigh Valley Health Network, working in the post-anesthesia care unit, which for the uninitiated is the area you go to recover after your surgery. And the point of the project was a little open-ended. It was, we know things aren't quite right, but we're not sure what it is, which is a theme I keep hearing as I enter project after project. And so I really went in there to do an open analysis, to look at throughput, to look at staffing, to look at things that just seemed off or inefficient. And in the end, it turned out to be about a 25-page report with about 16 different things that they could change. And we're still in the process of discussing how to implement some of those things. But what I was able to demonstrate through the use of simulation primarily, and it was a fairly robust simulation, so a lot of analytics in the data, a lot of determining distributions, running it through, testing out what-if scenarios, as well as an optimization model. We were able to figure out what appropriate staffing should be, when staff should start, and how to increase the coverage appropriately so that the OR doesn't go on hold and patients don't wake up after their surgery while still in the operating room.
David, you're
Mine's a little bit, obviously where I'm at in the program, I have not done a formal capstone project, but one of the things in terms of applicability at the end of December, when I was finishing up the quality course, our department was embarking on a new mission, which was to find a way to not admit lower risk chest pain patients into the hospital, and to try to rule out the possibility that they were having a heart attack while keeping them in the emergency department. So it was an interesting moment because I found myself, we have a very good team that works jointly, that are the physician and nurse executive team in our emergency department work together, but it was very much that moment of, how do I take these things that I've learned, particularly in the quality course, how do you set up this process that is both workable for the clinicians and particularly the emergency physicians who are unfamiliar with some of the things we were doing, but also make sure that it's safe, that we were not sending patients home after a period of time that were in danger, that we were doing this in a way that was both efficient and safe. And it was a huge challenge, and it was very interesting. We've done a lot of these projects before, but the difference between 2 or 3 years ago, before I got on the program, and now, I found myself, quoting you, I found myself talking about the things that I heard in class. I found myself approaching the problem in a very different way, and we had a great success in it. But again, it was, I thought about it in a very different fashion than I had previously, and it showed in I think how quickly we got the program off the ground, and how well it was adapted by the physicians, and how successful it was in meeting the mission that the hospital had put out for us, which was to reduce, quote unquote, elective admissions and to treat the patients in a different setting. So it had been very successful for us.
We also have on our webpage one of the projects that actually got published in Informs, and I'll let you read about it. It's about predictive modeling for home care, how to predict the patients that will be rehospitalized within 60 days in order to reduce the risks that are associated with that, and also to increase the pay that is associated with, or reduce the losses that could be associated with a rehospitalization. But Dr. Theman, if you can talk about your project that you presented at the Healthcare System Engineering Conference, because it's slightly different from the rest of the projects. It's more clinically driven, but it's about process improvement and process streamlining.
Well, just this project actually took its final form after I presented it informally to Dr. Nabaa. I had started doing some quality improvement work in cardiac surgery and submitted it in a hospital quality environment where it won an award, but it wasn't fully fleshed out. And after Professor Nabaa and I met, I went back and I re-looked at the data and reapproached the problem, and in fact was able to get it in a form where we were able to present it at a National Healthcare Systems Engineering meeting. And I've just submitted the manuscript now for publication in the Annals of Thoracic Surgery. So the idea here is actually very simple. The problem was that our cardiac surgery program had a higher than expected rate of taking patients back after heart surgery for bleeding. So the operation was completed, the patient was already in the recovery area, but the output of blood through the chest tubes was more than one would expect from these surgeries. And we weren't sure what the cause of this was. And when we compared our hospital's outcomes to those of comparable institutions in Pennsylvania and nationally, we were still above the norm. So we got data from a regional quality improvement organization, the Delaware Valley Society of Thoracic Surgeons. We took a team of clinicians, visited these 3 programs that had very low take-back rates for bleeding, and we were scratching our heads. We couldn't figure out what was different about these programs versus us. And we continued doing things the same way, and there was sort of an aha moment that came along by serendipity, where we noticed that if you actually made the decision about what you're going to do about the bleeding in the operating room as opposed to in the recovery area, it changes everything. And I didn't realize it at the time, but this in fact is process engineering. When you're looking at a process and you're manipulating, you're taking aspects of it and you're moving them around and then studying these metrics. And in fact, over 18 months during the study period, when we moved the decision point about bleeding into the operating room from the intensive care unit, our bleeding rate dropped from 6.25% to 1.3%. And it was dramatic. I've now expanded the study to include 5 other regional programs, cardiac surgery programs, just to be sure that observer bias isn't a factor in this process. I don't believe that it is, but this expanded study hopefully will help us. So we're collecting data for the next year from these 5 other programs.
Thank you.
What is the average age of students in the program? And how many years of working experience do the students have prior to the program? And how many full-time students are in the program?
That's a tough question. Never thought of it that way, but what would you say the average age of students? I mean, you've been in class.
I'm the oldest student.
Well, there's a dichotomy. There are a large number of what I would call it 22 to 25-year-olds just out of college.
Yep.
A lot of energy. And then there's those of us who are, maybe over 40 or more, who have had careers for a while. So I think it tilts more to the younger, but I don't know that I haven't met a lot of distant students. So it's a little bit different on the ones that I've seen that I'm not meeting. As
Most of the students that are distant are above 25, 30,
Nice.
to put it, because they do vary within that spectrum. But if we take the statistics that we've done in terms of working and non-working, approximately 47% of our students are working compared to the full-time students. And if you take that into account, that age sort of correlates with those that are working. They're more experienced, they're more into the field. Compared to our full-time students, they're fresh out of college or maybe worked a year or 2 and then took this program as a way to increase their opportunities of work and salary increases and so on.
I thought we had a slide that showed the demographics. I don't know if it's
Yeah,
on.
that was, yes. I mean, I can make it available, but that wasn't here today.
Another question on, have any of the projects ever dealt with medical devices in the operating room with unmet needs? So any medical device?
Well, we were currently doing a study with IV pumps, but it's not specifically in the operating room, but in general. There's something called smart pumps, which are still having a number of medical errors associated with them. They're not really as smart as they are called. So what we're trying to do through research is develop what we're going to call intelligent pumps that use mathematical modeling and predictive modeling to actually predict an error before it happens, instead of waiting on the sequential events to detect an error as it happens. And currently we proposed this idea to be Bronze, which is one of the known manufacturers of IV pumps, and they're very interested in the collaboration, but it's still in its preliminary stages. We try to avoid, as much as possible, getting into the technical aspects, although personally I would love to get into the electronics and programming of the electronics of an IV pump, but we're more of an industrial systems engineering compared to a biomedical engineering. A lot of the medical devices would be part of a biomedical engineering program, not as much as within the industrial and systems engineering or within a healthcare system engineering program.
This is for one of the students. Can you give an example of how the HSE program can increase efficiency and reduce cost within your field of work?
Sure. So I was hired into my position specifically to, I'll say, reinvigorate the use of simulation within the organization. The COO really got the concept of it and had wanted to see the management engineering department grow to bring that in. And the biggest benefit of simulation, and the way we sort of advertise it with our internal clients, is that it gives us a chance to try something without trying it. And when you talk about having to cut costs, a lot of times you're talking about some fairly sizable changes. You might be talking about moving walls. You might be talking about changing your ratios of nurses to physicians. These are things you can't really try. You can't hire a nurse for 2 weeks, try it out in a PDCA cycle and say, oh, that didn't work, sorry, see you later. That doesn't work very well. But with things like simulation and optimization, you get into the ability to say, well, this is what we do now, and if we changed it a little bit, this is what we would expect to occur. And so you can start testing out what's going to save you money and what's going to increase your throughput, get you more patients through the door, that sort of thing, without actually committing enormous amounts of money to trying it out in the first place, only to backtrack and throw your hands up in the air and say, great, another failure. So we've started doing that quite a bit. We're working both inpatient, ambulatory, with the technical groups and non-technical groups. So simulation has a lot of flexibility all over the place, and I think it's one of the biggest assets to this program is that simulation course is designed, and the professor has no problem telling you so, that by the time you finish it, you can actually go out into the world and build a simulation without a problem. And he's absolutely right. And I don't even use the simulation software that Lehigh uses where I work, but I had no problem adapting to it. So you're getting the skills you need, and they're transferable into the organization that you work for.
Just as a side note, if you had 20 processes in series and everyone was running at 99% efficiency, at the end you're at 70-some efficiency just by having these sequence. And one of the things that Dr. Theman was talking about is improving the process, is a streamlining of process streamlining, which is the process of looking at the tasks within each process to try to actually combine to reduce the number of series or the number of processes that are in series, because at the end you're really reducing efficiency. So this is something that we teach our students. This is a lot of the projects that we've currently been doing with Lehigh Valley Hospital, with Geisinger, with St. Luke's, has been, and Beata Home Care has been focused on streamlining processes and optimization of processes in order to get increased efficiency. This is something that you can't really, by intuition, be able to figure out. This is something that you really need sophisticated computer systems and modeling to be able to run every possible scenario in order for you to get that optimal scenario that will give you the best results within any given process.
It's like a two-part question. Is Six Sigma or Lean certification part of the program? And what would be the difference if someone would take the Black Belt Lean Sigma certification for healthcare versus healthcare systems engineering?
I'm going to let Robert answer part of that question because he just got his green belt process. But from our perspective, we don't give a certificate. We're, from an educational perspective, we have our quality course, healthcare quality course, which covers certain aspects of the Six Sigma. It gives you the tools. Basically, we talk about all the quality tools and how to use the tools, and even some of the more advanced tools. We also try to use in our computer science course, like for example the use of Microsoft Access and other softwares, it's in a simple introductory way of what are the possible tools out there. If you want to get more specialized and more detailed information, you can take the route Robert has taken, which is take a course. I'm not sure, you can talk more about the details of that course, but it's outside Lehigh where he went and got a certificate as a green belt. If you can.
I did. Basically, I wanted to add a little more to my resume, and in doing so, I had a break between the spring semester and the summer semester. So I signed up for the Greenbelt course, and it took me, I guess, about 30 to 40 hours worth of studying to get done, and it was a lot of material that we're already familiar with because of the courses that we take here. I thought it was a great, enriching sort of experience. I now have a belt, and I'll probably go on to get a black belt in the near future. But I would say that while it is a nice certificate to get, there is going to be some overlap between the courses and what you'll learn getting a certificate. I definitely felt it was a good decision to do, and I will continue to do so. But you'll get a lot of what I feel you need through the courses here at Lehigh.
Is the program accredited, and if so, by whom?
At a master's level, it's on a national level. Middle States hasn't accredited, as to my understanding, and I could be wrong. Graduate level courses like ABET that would do for an undergraduate program. So it's not accredited like ABET, and that is generally the case for majority of graduate programs in the country, except if it's a licensed program like in a medical nursing and so on.
How does HSE affect you in your area of work?
Yeah, I'll take that one. I think it's impossible to separate out what I learn in class from what I'm applying for us, it's Thursdays when I'm doing my administrative time, when the exec team is together and we're talking about new concepts and how to implement them. And then also, what Terry had mentioned, which is, it's kind of like all of a sudden you're seeing in color where you're seeing in black and white. You start looking at the systems around you and go, yeah, that makes no sense. Why are we doing it that way? Understanding what the bigger picture is and where you fit in. Because we sort of have this continuous process improvement where we're just continually modifying our system. Sometimes our modifications get ahead of where we think we're going to be, and then you end up finding the ways to backtrack and providing sort of the rationale for things. We undertook to, in the emergency department, the traditional model is patients come in, they're triaged, which is usually a full process. Maybe you add a physician in triage because that tends to be the bottleneck, so you get the physician to see the patient. And then there may or may not be some delay before you get into a bed where their more definitive care is being done. We had all those pieces. We had put a lot of time and effort into our front end. We had built a beautiful new ER that had a great triage area. And then we decided that that was taking too long. We instituted a process through a lot of the concepts that I've learned here, where we put a nurse out truly in the waiting room to pivot the person to an abbreviated triage and then expedite them getting back into a bed. The interesting thing is that we no longer have the physician in triage because they're getting seen by the physicians and back. And this beautiful area that we built that had diagnostic rooms to draw blood work and do EKGs, and the 5 bays we had for triage are now completely empty because the patients are getting back to where they need to be, which is in a room and being cared for by the team that's going to be doing their definitive care. And what we've realized is that we've kind of rewritten the book, and a lot of that was based upon, the concepts that I'd learned here and then going back and implementing it. So it's very hard to separate when you're a clinician from what you're learning from experience and what you're learning in the classroom, because they interact with each other pretty strongly.
I remember, Terry, you mentioned something about algorithms and how they affected the blood infusions.
Well, one of the newer concepts in cardiac surgery are what are called integrated or team rounds. So when you have postoperative patients, we go around with a team of people. In years past, postoperative care of the cardiac surgical patient could be fragmented. And a lot of programs, it was just managed by the cardiac surgeon. Some programs by intensivists, others by anesthesiologists. But it was rare that you actually had all the people involved in the patient care together. So in the last, I'd say, 5 years or less, it's become the style in this country anyway to bring the team together in the morning, usually around 6:30, 7 o'clock in the morning, and you go and you see every patient, and you get input from pharmacy, nursing, physical therapy, the social service people, the respiratory people, as well as the surgeons and so forth. So it's become somewhat ritualized. And as a result, they've developed some formal and some less formal algorithms. And some of them are actually don't make any sense, but we do it all the time because and everyone's comfortable with it. It's almost like a chant. And one of the chants is that if a patient's hemoglobin is below 10, well, we're going to transfuse this patient. And this led to a lot of wasteful and unnecessary blood transfusions. So I started going through these processes of these various algorithms and asking questions, which I think prior it would not have occurred to me to start asking questions. And why are we doing this? Why do we have this particular algorithm? What's the evidence that supports us doing this? Why do we try to make every patient fit in a certain algorithm when some patients are 40 years old, some patients are 85 years old. Clearly they have different needs, and not everybody's going to be able to be treated based on the same transfusion trigger. This clearly makes some people uncomfortable within the system, and I don't want to say that if you take this course you're going to develop a lot of enemies and things, but you will arouse interest and curiosity and questioning, because I think these are important things to be asking. We already know that about 30% of the things we do in medicine don't actually contribute to the well-being of the patient. And if you go to physicians and you toss out that statistic, they'll all agree with you. Yes, absolutely, but it's not them. They practice perfect medicine. It's the other guy. And the truth is, it's very hard to look at ourselves and to be very critical and look at all the things you do and see what it is that's truly bringing value to that patient and what isn't. And I think this course really, it causes you to develop a certain discipline and a way of looking at things that is unique. Certainly was unique for me.
We'll take one last question. To what extent are human factors and ergonomics methodologies and theories covered by the courses or practiced in the projects?
Again, this is a field that is mostly covered by healthcare administration, healthcare MBAs that concentrate more in those fields. We don't have a dedicated course to those human factors, although they're an important element. For example, when we're modeling medication errors, human factors like the Swiss cheese model of James Reason and other models of trying to capture the human factors as a part of medical error is something that we study, but it's not something that it has a dedicated course. We might elaborate about it. We might talk about, for example, change management, human factors, and other factors that might be affecting, but it's not an area of focus. It's more based on project-based or more specific topics. Again, what we're trying to do is teach the tools, not the specifics of a narrow field or a subspecialty within the healthcare industry. It's more of the tools that you can use at a broader sense, and then you can get into the details based on the project or based on the work field that you're actually in. Well, thank you very much. And again, on the slide, you will find my contact information and Linda's contact information. Please do not hesitate if we didn't answer any of your questions, or if you've thought of a question later on, to contact me directly, and look forward to seeing you on campus for a tour.